Hello world, this is JWP, J Ward Primo Beats, coming to you live from my bedroom. Check me out on YouTube at JWPTube, Twitch, JWP Stream, Facebook, JWP Meta, Patreon, JWP Patreon, and Discord, link in description. I will be looking at the SynthEdit book entitled Visual VSTi Programming and documenting that going forward. For now, this will likely just be an introduction. So might as well just get right into it. Not sure what's going on with my volume. Wrong button. All right. Visual VSTi Programming, a comprehensive guide to creating VST effects and instruments with SynthEdit. A cookbook for SynthEdit maniacs. Build your own VST effects or VSTi without higher programming languages. Easiest way to start successful VST/I programming. So this is mostly going to be a lot of reading for me on my part. And that's generally what this section of this series is mostly going to be. And we have the authors there. And everything I just said already. Some publishing notes. Forward by the editor. I'm not sure if I want to read that. I suppose I could. Perhaps I won't. So I'm doing my best to just stick to the content. Not sure why I have this extra bar up there. Let's see if we can get full screen mode. Okay. So we'll jump right through it. Here's the table of contents. I'll just read the chapter headings. So welcome to the wonderful world of SynthEdit. It's chapter 1. Chapter 2. If I can get my screen to not bounce around like that. Designing VST effects in SynthEdit. It's a big long chapter. Chapter 3, stepping up to synthesis. Chapter 4, making the most of performance. Chapter 5, all about subcontrols, appendices or appendix and index. Chapter 1, welcome to the wonderful world of SynthEdit. Save often. What is SynthEdit? What's SynthEdit? Decades ago, synthesizers were ponderous beasts with a nest of wires sprouting from their panels. To create sounds, one would plug these patch cords into different modules such as oscillators, filters, envelope generators, and amplifiers. The signal path, that is, the order in which one connects modules, shaped the sound. Hardwired synths, far easier to port and use, later won the day. Modular synthesis reared its head again in the arrival of digital technology. SynthEdit is a software application enabling today's users to build audio applications taking the modular approach of yesteryear. Its modules put many processing options at your fingertips. Few who practice the cumbersome chore of juggling real patch cords would contend that plugging in a virtual patch cord is anything but a quantum leap inconvenience. VST technology. Storability is what makes SynthEdit stand out in the crowd of modular software applications. Create a synth or an effect, save it in VST or VSTi format, and you may share it with or sell it to people owning VSTi compatible hosts. A trademark of Steinberg Media Technologies, GmbH, VST stands for Virtual Studio Technology. Steinberg rolled out Cubase VST for PCs in 1996. VST instruments and effects are separate modules rather than features of the main application. In 1997, Steinberg released the format as an open standard, inviting third-party developers to market their own plugins. SynthEdit is a fast, convenient tool for creating VST/I. Put it in the hands of people lacking programming experience or deep DSP knowledge, and they can still deliver the goods. Courtesy of custom subcontrols, you can skin and customize the GUI just about any way you see fit. And with the many built-in and third-party modules, you have View, Coop, sound sculpting tools at hand. I've never heard that expression before. What's a VST plugin? Typically, a VST plugin is a Windows DLL module that loads into the host application, whose numbers are growing in at a scary rate. Instruments usually produce sound and lack audio inputs. MIDI events such as note on, note off, control change, pitch bend, and mod wheel messages serve control purposes. Effects plug into individual audio tracks or master buses, inserts, or sends, depending on host. Most feature one or more inputs and outputs, and a set of adjustable parameters. A VST plugin comprises a DSP module that performs the actual processing, and a graphical user interface, or GUI for short, GUI. Some VST plugins lack a GUI, relying on the host panel for parameter adjustments, though most offer one. It lets you tweak and toggle to your heart's content various graphical controls such as knobs, sliders, buttons, list boxes, text entries, and so forth. SynthEdit VST plugins always feature a GUI. The Save As VST command automatically creates the VST parameters the host and plugin need to interact. End users rarely see anything other than the GUI. The SynthEdit structure window opens by default when you launch a new project. It shows the DSP module, that is, the plugin's internal structure. The panel window opens on your right-click the structure window and select Panel Edit. It lets you edit the GUI. The section where our subcontrols from page 193 onwards discusses graphical features in their properties in detail. The following sections deal mainly with DSP effects and synth's underlying module structure. 1. Oh, it's on the back. X-raying SynthEdit's hierarchic X-raying SynthEdit's hierarchic structure. Modules. Modules are the building blocks. They appear in the structure window as boxes with various inputs and outputs. Figure 1.2 shows a Moog filter module with 3 in plugs: signal, pitch, and resonance on the left, and on one out plug on the right. The signal out plug of a slider insert controls slider connects to the pitch plug. So the slider controls the filter's cutoff frequency. Heads up, adding modules using the insert menu in the menu bar or the structure window's right-click menu. Some modules are built in, others appear in the default SynthEdit folders module subdirectory. SynthEdit automatically lists all folders and modules found in the modules directory, so you can create folders for third-party modules and copy the modules there. Plug types. Voltage plugs. Most plugs are blue voltage pins. They serve mainly for audio signals and control voltages. The standard range for the control voltages is 0 to 10 volts and -10 to +10 volts for audio signals. Plugging 2 or more cords into the same input adds the signals. List plugs. Some modules' plugs colors vary. For example, an oscillator, insert waveform oscillator, has a green waveform plug. These plugs reference list sections, meaning the green input plug only accepts list plugs. These include list entry 2, insert controls, and voltage to list, insert conversion modules. A list input accepts one input only. A list output, in turn connects to more list inputs, but only if they are the same type, such as waveform selector or 2 oscillator modules. We can see some graphics here. There's the Moog filter with a pitch, a slider, It's plugging into the pitch, and it's all SynthEdit 1.1. Now we have a list entry here, and it's plugging into the waveform. Of course, there's no color. Must have been way back in the day when there's no color. Always cheaper to manufacture books without color, right? Float pins, serving mainly to communicate with GUI modules. These plugs come in different shades of blue. Float denotes the data type. They may have any real number value. So we have float. And of course, again, we can't see the colors. It's float to volts. MIDI plugs. The green MIDI in and MIDI out plugs shuttle MIDI data, such as note on, note off, pitch bend, module wheel, after touch program change, and control change events to and fro. So we see a MIDI player. And of course, again, no colors. I do believe they are, well, it says green. Text plugs. Though these crimson text plugs enable mainly file name entry as shown in figure 1.5, they also serve other purposes. GUI text plugs, for example, provide caption titles for subcontrols. See the section What are subcontrols on page 193 for details. Spare plugs. One SynthEdit plug type automatically clones itself when connected to another module. For instance, a switch. Insert flow control switch many to one. Connect the module's output to a spare input plug of the switch, and another spare input plug appears. This means you may connect as many inputs as you wish. Spare plugs may appear either as inputs or outputs. So we now have a picture of a bunch of filters plugging into a switch, and we see on the bottom there is a spare input. So plugging in more filters will add more options, and then the spare input will always stay on the bottom. GUI plugs. Some plugs' background is blue rather than gray, called GUI plugs. These serve chiefly to communicate with the GUI and all subcontrol modules home. What sets GUI plugs apart from regular plugs is that they are updated less frequency, about 20 times a second. To learn more, see the sections on GUI plugs and subcontrols. To my understanding, the GUI plugs update at the computer screen's frame rate. So if your computer screen is running at 30 frames per second, the GUI will update 30 times a second, opposed to DSP, which updates, I believe, at the speed of the selected sample rate, which is generally 44,100. So yes, the audio system is updating 44,100 times a second, apparently, to my know. As far as I know. Module properties. Every module offers a property window. Right-click a module and select properties. A window much like this appears. So in 1.4, this is now on the side here. So if we bring something in, there's no parameters there. Something like this, we can see these are the properties. This has replaced the properties window. And on the list here, module. Rename the module any way you see fit. The new name appears on the structure window. So that would be name here. Plugs. This lists input plugs and their default values. Feel free to set a default value for any plug. Note that connecting an input to the plug overrides the value entered here. So that would be, this obviously that's an output plug. That's a slider, and that's the value that's going out. Options. Some modules' advanced settings may also be changed in the properties window. For instance, frequency scale 1 volt per octave or 1 volt per kilohertz as resolution settings. So sometimes there are we can see on the left here we have all the plugs listed. I call them pods. Plugs listed. And on here we can see there they coordinate. However, we have some extra stuff here as frequency scale, as was mentioned, 1 volt to octave, 1 volt to kilohertz. So that's not available here, but we can switch that internally. And then the 1 volt will represent 1 kilohertz opposed to 1 volt to octave. And it has the logarithmic or exponential response to 0 to 10, which is generally a volt range. And also we have, looks like, Smooth peaks, if we leave the most highlighted, it's supposed to say, must be Gibbs effect, smooth peak, Gibbs effect. It doesn't say. Sync X fade, anti-alias. So these are just for cleaning up the oscillator a bit more, as far to my knowledge. CPU. Appearing below the options is a graph showing CPU use and history. The green dots as the upper left shows polyphony. See this section, polyphony, on page 21 to learn more. So this is no longer the case in 1.4. If we right-click, we go more, we go debug. We now have our CPU usage, and we can see the oscillator is not sleeping. And we can give it a bit of wake it up some more, make it do things, and it raises in CPU usage. And then when we leave the control alone, it falls back down. However, it is still generating a wave, as there's no VCA or ADSR envelope generator stopping it from generating a wave. Prefabs. SynthEdit lets you load a full set of modules called a prefab, consisting of several modules, anything from a flanger to an LFO to an entire synth goes. Prefabs are usually large and easy to insert. They often hold modules in a container for easy handling. You will find them in the prefabs folder. The insert menu lists SV1 files, copy frequently used setups to it for easy, quick loading. That was a bit of a tongue twister, maybe a brain wrapper. Again, 1.4, what does it say? Inserting a prefab can be done from, I believe, I'm not seeing it anywhere on the menu list. It is included in 1.4, however, it's in the old view. If we right-click and we go insert, we have the insert menu, and it has the list of all the modules, and on top here is prefab. However, if we go into the new view, our 1.5 view, we right-click, we no longer have the insert menu, and there is no insert menu elsewhere. So I do believe 1.5 has addressed this. I'm not sure how we do this, but in order to get a prefab in 1.4, we have to go to the old view, and that's just by entering a container without holding shift or shift double clicking, and right click insert, and then you can get your prefab there. Be forewarned that the old view does take a little while to load, so preference is to go to the top main, the parent, and then just insert your prefab there and drag it into whatever container you need it in. As well, if you put any SE1 file in, if I got this correctly, your users. So if we go C drive and we go users, public users. Oh, I think I went into Windows. No. Users, public documents, SynthEdit projects. We have prefabs here. And I do believe that when you insert a SE1 file in here, you get, it'll show up in this list here. And I have a couple meters that I've made that I quickly just grab. However, it looks like they're the SE prefab. So I'm not sure how I pulled that off. Maybe save as. I must have created it somehow. I think maybe like this, right click a container, more, and then selection to prefab. And this will create a prefab file. However, SE1 I do believe does work too, or the SE prefab file. So we got a picture of a polysynth. The polysynth, it's just a container that says polysynth, and it has its preset browser on the bottom, which is in black with the edits and that stuff. Let's figure 1.9. Containers. Containers are key building blocks in SynthEdit. They round up several modules, herding them into one logical corral to simplify the structure of a synth, effect, or control feature. Every container affords you a view of internal structure and panel window. Below, you see the structure of a flanger prefab loaded into a container. So we see a picture of SynthEdit 1.1 that has several modules, specifically a delay module, which is linked to an oscillator, and that oscillator is linked to a rate. And that's what generally creates a flanger or flanger. And then we have another smaller picture layered on top of that, and it shows 3 controls that control the flanger or flanger: rate, mix, feedback. An IO mod feeds the audio signal into the container. The delay 2 and DCA modules, DCA digital controlled amplifier modules. Okay, I'll start again here. An IO module feeds the audio signal into the container. The delay 2 and the DCA, digital controlled amplifier module, delay the incoming signal and adjust the wet signal level. Another IO module routes it out of the container. The original dry and wet signals blend to create a typical flanger or flanger effect. Check out the section Conjuring a Flanger on page 69 for more on flangers. So the whole flanger thing, growing up for me, was always flanger, and then everybody else was calling it flanger. So I don't know if it was some sort of what's it called, Mandela effect or whatever. So going forward, flanger is now going to be flanger because apparently that's what it's supposed to be called. After creating a container, insert container, double-click it to view its structure. The application automatically generates an IO mod. Feel free to use the same module for outputs, but note that creating another IO mod devoted to the outputs makes it a tidier setup. Controls on module/parent. Right-click a container and select properties. The following panel pops up. We have a pop-up of the container for the right-click properties, and we see module, help, title, flanger, plugs, label, default units, controls on parent, controls on module, ignore program, change signal in 0 volts, output 0 volts, options, label, default units, polyphony 1, CPU, and it shows like a graph, and then skin default. Enable controls on module, and the structures windows container box shows the panel as in figure 1 and 2. Enable controls on parent. These controls also appear in the main container. You can handle them as one group as shown in figure 1.13. This method goes for all control features with subcontrols: knob, pitch bender, list entry, joystick, LED, and VU meter. So figure 1.12 is another picture of a container, and obviously they've turned on modules on controls on module. So in the structure view, we can see the 3 sliders. And first one, rate, second, mix, third, feedback. And now we have figure 1.13, which is the panel view. And again, it's the same thing with a bit of a background: rate, mix, feedback sliders. Lock containers. Lock a container if you wish to prevent further editing. Lock a container if you wish to prevent further editing. Simply clicking the lock icon in the toolbar locks the active window, or right-click the container module and tick locked. The spare plugs disappear when a container locks, deterring you from adding connections. The box icon in the container heading shows the status. An open green box stands for unlocked, a closed gray box. Closed gray box locked. So again, this is different in 1.4. I'm pretty sure I've covered this in the past. On the old view, we do have this lock button here. It makes it disappear. We can open it back up. Not really disappear, but it kind of zips its controls. This is the 1.3 view, I'd say. And then the new view, we no longer have a lock button on the bottom. We have no buttons, in fact. But if we right-click the container and we go more, we now have the locked function here. And it doesn't actually seem to do anything as far as removing those spare options to plug things in or out. I'm not sure if it will keep us from connecting things. I don't think it does. So generally what lock does is just, in 1.4, it just, in the original view, the 1.3 view, it'll sort of reciprocate those controls, but 1.4, it's kind of useless, I imagine. Polyphony. Containers are the key to managing polyphony in SynthEdit. So let's back up and look at what polyphony is all about. A MIDI to CV module automatically converts incoming MIDI data into control voltages. Press several keys at once on the MIDI to CV module produces a polyphonic signal. The application creates ever many clones, all the downstream modules needed. Generated internally, these clones are invisible to us. When the signal leaves the container, the application shoehorns it back into monophonic format. A container's default polyphony is 6 voices. Give figure 1.11 another gander and note the option called polyphony. You may set it to any number up to 128, the MIDI maximum for voices. This, of course, limits the number of voices and clones created during processing. Heads up. The polyphony setting affects MIDI to CV modules. A container or subcontainer holds just one MIDI to CV module. You cannot dial in different polyphony settings within the same container. The properties window shows the number of active clones for each module. Figure 1.14 shows the bottom of an SV filter's properties window. The green dots at the CPU's graph top left signal the specific clone is active. In figure 1.14 scenario, max polyphony is 4 voices, with 3 currently active. So we do have a picture 1.14. It shows, I believe, a container or options. It's sort of trimmed. We can only see the bottom, and it just shows options, and the headings are labeled default units. Frequency scale, that's part of the options, and the CPU meter, which has 3 clones visible or active out of 4. However, it's quite hard to tell that they're green because it's in monochrome. But we can clearly see 4 boxes, and 1 is dimmed. And it's running at 4.12% of the total CPU allocated to that module. More notes, more heads up. Use the special voice combiner module to manually convert a polyphonic signal into monophonic signal. For instance, to elicit guitar stomp box-like distortion from a waveshaper module. Polyphony is more complicated. Some modules force the signal into a mono format. For example, delay 2, level adjuster, and pan, which every clone shares the same settings of these modules, sits at the end of the chain. Apply the effect to each voice and combine them, or combine them and apply the effect. The outcome is the same. But inserting these effects before polyphonic modules imposes polyphony on them. Say you're dealing with the following setup: VCA poly to pan mono to delay 2 mono. You decide to add a wave shaper for delay 2, forcing all the modules, including pan and delay, into polyphonic operation. This wastes CPU resources. So economize by inserting a special voice combiner module before pan. The distortion will, of course, sound different. So I've touched on this before. Polyphony is quite a complicated subject, especially in SynthEdit. So watch out for squishing your signal. One of the main ones I'd say to watch out for is using a polyphonic signal outside of a container, like routing it out through an I/O module, because that'll just make it overload and it doesn't sound cool. Skins. Use your main container to select a skin for your plugin. Choose either the skin option in the container's properties window or right-click the container's panel window and select the skin menu from the list. So skin in the standard view is not apparent. I'm not sure why not. So if we head into a container to the new view, it's on panel. So we go to panel edit and then we right click there. We have the skin menu there. As well as in here, in the new view, same thing. Panel edit's the same, unless you go into the old panel edit view, and I'm pretty sure it's still the same. So that's where it's at. Automation. The right-click property lists all automation parameters used in the container. You may define automation parameters specifically for one patch or globally for all, and configure them as VST parameters or MIDI continuous controllers for users to access. So again, the automation has moved to the left. It is no longer a separate menu or right-click. So if we head into here, we dropped a slider or two, and then we're on top here. We now see both sliders, and we can name them or edit their values, ignore program change, privatize them. Privatizing a module or a control, whenever you see that, that just makes it so in the host that the parameter is no longer visible, no longer editable. I'll also remove the MIDI automation function. And of course, in here we can see the MIDI automation function. Edit, learn, unlearn. Modules prefab categories. Add modules and prefabs in the toolbar insert menu or right-click menu. They are grouped in different submenus, the default categories being controls. This menu comprises mostly of parameter controls such as knobs, sliders, switch, list and text entry boxes, mod wheels, pitch bend, joystick, and keyboards as shown in figure 1.15. In figure 1.5, we have a joystick, a knob, a smaller knob, a mod wheel, a bender wheel, a switch which kind of flicks on or off, a list entry, a text entry, list entry 2, a keyboard, and a slider. Note that the slider offers an appearance parameter listing various sliders, knobs, and buttons for selection. Predating subcontrols, these are the original SynthEdit controls as shown in figure 1.16. You can skin all the controls shown here and create new types of subcontrols. See the section What are subcontrols on page 193 for details. So I know I've never seen these before. So these are the original controls. And we have it looks like a Windows native slider. So the visual that comes out of, I'd say Windows XP. It's probably when that slider stopped. Nowadays, the Windows native slider is a little more vectorial. I guess that's pretty vectorial. Then we have a horizontal slider, vertical slider, a small knob, a plain button, a button, and a small button. The original SynthEdit controls. Visual feedback modules also fall into this category. This group includes the frequency analyzer, LED indicator, peak and VU meters, and a voltmeter as shown in 1.17. So in 1.17, we have a few more things here. We have the frequency analyzer, a peak meter, 2 LEDs, actually 4 LEDs. It looks like maybe one is on and one is off, and then the other one might be green, one is red. We have a VU meter, LED indicator, which is a smaller LED, and voltmeter. The two other modules merit mention: fixed values and image. The former produces constant output voltages. The latter displays PMP or PNG images on the GUI. So what is this referring to? This is referring to just the list here on the side. We right click that and we got all those there. I also have a couple more meters in there. Those are the ones I created as a prefab. Other than that, these are what it's talking about. Conversion. This category's modules convert data types, for example, floats to volts and vice versa. In the conversion, we have many conversions. In the past, SynthEdit 1.1 required these modules to convert most data, well, actually all data. So if you wanted to go from, say, float to integer, you'd need the float to integer DSP module. However, in 1.4, most of these automatically convert. For example, if we have a slider with a volts out, we can see it's blue, volts out, and we connect that to, say, an integer, so the integer in, it'll automatically convert, sort of behind the scenes kind of thing, which is very much appreciated and quite tidier for workspace. However, that does not apply to subcontrols. The subcontrols still all need their conversion modules. You can't just directly connect, for example, an integer or a float to, again, an integer. So switches and integer, so we can't just directly connect these. It'll throw a warning dialog saying can't connect these plugs directly. Example, you can't connect a voltage pin to a file name. Consider using a converter module. Effects. This category's defaults are delay, flanger, chorus, ring modulation, and hard clipping distortion modules and prefabs. A clipper module lets you restrict control voltages to any range of your choosing. So again, we have the effects over here. Not as much has changed. We got a couple new reverbs, soft distortion. Other than that, the originals are still there. And the clipper is this here. And this will, in fact, restrict values. Examples. This category offers sample prefabs serving to do things like create low-frequency oscillators or a page panel. You are sure to find these examples are edifying, so be sure to check them out. So if we go into examples, we have quite a few things. Open web page, page panels, radio buttons, tempo sync LFO, step sequencer. Whoa. And the like. Definitely something to peruse if you're a new user. Filters. These components cut frequencies from a signal. Filters come in various guises with different characteristics. The most significant difference is the number of poles. The more poles, the steeper the cutoff slope and the frequencies they let pass. Low pass allows all low frequencies to pass, filtering out frequencies above the cutoff. High pass allows only high frequencies to pass, filtering out frequencies below the cutoff. Band pass allows only a narrow band of frequencies around the cutoff to pass, filtering out both low and high frequencies. Band stop filters out a narrow band of frequencies around the cutoff too, allowing all other frequencies to pass, also known as band reject. All pass allows all frequencies to pass but changes the incoming signal's phase. Phase effects usually feature this filter. Single pole low pass. Filters also serve to smooth parameter changes and create a portamento effect. Use negative voltages for smoother transitions. See portamento example on the disk to learn how to create a portamento by applying a one-pole low-pass filter to an oscillator's pitch. A one-pole high-pass filter set to 20 to 30 hertz serves to remove digital DC or digital current. Check out DC filter example for more on this. I'm not going to elaborate on any of that. Filters are a whole different game. I'm sure we'll cover them. Flow control. Switches let users configure. Well, actually, I should look at the filters here. So filters are here. We have the one and the one pole low pass, high pass. And there's the all pass. And of course, the Butterworth filters, which will overload if they're too close to the Nyquist or the zero. Moog filter, which is a distortion type low pass. Octave to hertz or passband, I'm not sure what that is, and what's likely not going to be covered. Sync high pass, sync low pass. So these are linear phase filters included by default with SynthEdit 64-bit. This are not available in SynthEdit 1.4 32-bit. State variable filter 2. In my experience, the high end it is boosting, so it's not good to put these in serial. For example, putting two together and having like the same controls plugging into both, and then trying to get harder slope out of them because they boost in the high end. They don't have I believe this is to avoid EQ cramping for the low pass. I use myself the older state variable filter, as it has the band pass or the low pass doesn't boost in the high end when pushed up. So this would be the one if you wanted to put them in serial or in series to use. And there's a couple more filters here. It looks like the Korg filter and the Moog filter. Again, these are saturator types. I think one is hard clipping and one is, how you'd say, overdrive. I could be wrong. It's more likely that I'm wrong. What would it be? One's overdrive and one foldback. I'm not sure which is which, but I know pretty sure one is foldback and one is overdrive. And yeah. So flow control. Switches let the user configure patch cores and choose sound shaping options. For example, to select an LFO's destination and signal processor, Figure 1.18 shows how a switch works using a DC filter prefab. From the preceding example, the choice lists plug lets you select cutoff frequencies in 0.2 or 0.25 and 0.3 increments, or 20 hertz, 25 hertz, 30 hertz in a 1 volt to hertz scale. So we have a picture here of an in and out mod, and that's plugged into a signal of a one-pole high-pass filter, and then we have fixed values plugging with the values 20 hertz, 25 hertz, 30 hertz plugging into a switch, many to 1, and then the description on the switch is 3 decibels at 20 hertz, 3 decibels at 25 hertz, 3 decibels at 30 hertz, and that output is going to the one-pole high-pass pitch input, and the output of the one-pole high pass is going to the IO mod, which is outputting. So it's demonstrating the switches here, which is under flow control. We have the switches 1 to many and many to 1. And again, these are the ones that if you keep plugging into them, they will continue to generate more pins. And then you can then choose from a list entry which is which selection is going to be happening. And to change the names of the choices, you actually have to get in here and change the names. So it's a 1 and 2. And again, just to be completionist type, I can never get it to work. Okay. And then they'll show up here. And the list entry will populate its names from the last plugged in value. So this is AB. So because this is getting plugged in last, that's what it'll show. It's going to be AB instead of 1 or 2, even though these are labeled 1 and 2. Input output. Use the sound in and sound out modules to access your audio card's input and output channels. Note that the unregistered version confines you to just 2 output channels. Wave player and wave recorder modules play files from disk and record any audio signal in different wave formats. So input and output, a good example to demonstrate here would be in the synths here. We have the minimal synth, which already has the sound output, so it's ready to go. Of course, I can't hear anything because something's wrong with my input-output capabilities. I'm not sure. I think I might have my microphone selected. Yeah, of course. I don't know why it defaults to that all the time. And I still can't hear it, so some other time. And then the sound in, this would generally be for testing. I don't know if you wanted to use your microphone to test, say, a vocoder or an effect chain. You'd plug them into a container. Sound input. I'm just going to turn off the system, and then internally you'd route them through your effect. It's funny there's no examples for effects. I guess a good example would be a clipper, and then you just route them out, and then it would come in from your sound card and then output to sound out. And these inputs and outputs are configurable in your preferences. And I have FL Studio as you're running right now, so I don't want to open it up, otherwise it'll crash SynthEdit. But then whatever your sound card's dialog would be, you can configure your input and output from there. Logic. SynthEdit comes with logic modules that use control voltages to transfer data. 5 volts is the high value denoting true, 0 is the low value denoting false. This category also features different counters, a shift register, and a monostable module for creating a pulse with a fixed length. So these are the logic modules. They are quite a bit to deal with. You need to figure out where you need to use them and how they operate. Something that's not in the module section or the logic section, but that is kind of logic, I believe, is the comparator. And that's under modifiers, comparator. So this operates sort of like a module, logic module. It compares when value and outputs high or low, which often comes in handy and is pretty much comparable, no pun intended, to the logic modules. Math. This group contains basic math modules such as multiply, subtract, and divide. An add module is not on board because simply connecting any signals to the same input adds them. The floor and ceiling modules round voltage input down and up to the nearest whole number. For example, floor rounds 1.45 down to 1 volt. Ceiling rounds it up to 2. MIDI. So we'll look at that real quick. Math. We do have the ceiling and the floor, as I was just talking about. We also do have a new RMS module. However, its response rate is still a bit of a mystery, as there's no help for it. And subtract, multiply, and divide. And as it's stated before, add is just putting two values together. So we can create something like an add by having two. That's the wrong section there. We could just add things together, say a slider and a fixed values. And the fixed value can go into a container and the slider into that same pot or patch. And then whatever's on the fixed value, say 1, will add to whatever comes out of the slider. And then we can route it through. And on the other end, we can have a voltmeter. And of course, this is an add. Just call it add. And we can see it's 1, and then we bring in the slider, and it'll display whatever's the product, I believe is the right word for arithmetic addition. It's been a while since I've been in grade 1, so. MIDI. This category's modules mainly handle MIDI data, filtering it, playing it from files, and converting it to control voltages and back to MIDI. The menu also features MIDI sequencer modules, a MIDI sound font player, a patch select module for adding patches to your plugin, and a MIDI automator module that lets you automate controls using a MIDI mod wheel or controller commands. So in the MIDI section, these are quite a few important controls. If you're building a synth, you definitely want a MIDI to CV. I don't mess with the MIDI player too much. MIDI to gate is a little newer. Oh, not that one. So trigger to gate will create a MIDI note on, note off with pitch and velocity from a standard volt signal. We also have the new volts to MIDI CC, which is interesting, as 1.4 cannot output MIDI CC data or any MIDI data for that matter. So the MIDI CC data is limited internally, which makes an interesting prospect. We have controllers, so it's sort of the same as volts to MIDI CC. However, this is, for example, MIDI CC to volts. So it's sort of the other way around, right? No expression. This is specific to, I believe, Cubase. This is one of its functions Cubase has. It is quite extensive, and something like FL Studio can't access these values. Only specific hosts or DAWs that have that functionality can use note expression. Patch Automator, this is the old view. If we bring in the new view, it doesn't show anything. We have to sort of build our own Patch Automator. However, this is important to create presets. Preset Browser, this is the new sort of Patch Automator that we've seen here. We have the file copy and forwarded back and stuff there, but that is no longer available. We have to build our own preset browser. Polyphony control, that's a whole video in itself. That's a whole series of videos. As I said, polyphony is quite complicated subject. And that looks like generally it. MIDI to gate, this was to repair something or something. I don't know. MIDI message. I've never seen this before. That's new. It's interesting. Guitar dechannelizer. I believe this is for a MIDI guitar. And MIDI filter. This will filter out any incoming MIDI. So only the MIDI values that sort of fit within these parameters will pass through. MIDI in is just to bring MIDI in from a host or from a MIDI device, and MIDI out will, in the SynthEdit environment, export any MIDI data out. And it will work in the SynthEdit environment, but it will not work in a 1.4 build. I do believe 1.5 has this option. However, there is still no MIDI in. Everything comes in MIDI in, channel 1. That's all there is. It looks like I've covered everything there. Modifiers. This broad category features modules for adjusting levels. VCA, voltage controlled amplifier and level adjuster. Crossfading X-mix, panning, and inverting. 2 wave-shape distortion to signals or impose a customized transfer function on the control voltage, say a specific velocity curve. WaveShaper lets you draw the transfer curve manually by dragging points, while WaveShaper 2 accepts a mathematical equation. A rectifier inverts voltages charge from negative to positive. A comparator compares two levels. A peak follower tracks a signal's envelope. The quantizer module constrains the number of input steps, much like bit reduction. Use this to do things like confine a slider or a knob's output voltage to whole numbers. Simply add sample and holds the incoming level until it is retriggered. So those are, again, a whole selection to be explored, as they would require just pretty much their own videos to describe. Obsolete. This category contains an ancient version of delay for compatibility. Use FX/delay 2 instead. And we have figure 1.19, wave shapers. We see wave shaper and wave shaper 2. Wave shaper shows the plotted curve on a graph where you can move around the points to change your curve or transfer function. And then wave shaper 2 shows a graph with a representation of the mathematical equation plugged into it. Additionally, there is also a wave shaper 3, which is just wave shaper 2B, rather. That is just a formula. It doesn't show a visual. So you plug in the formula and your cycling in and out, and it'll do pretty much exactly what wave shaper 2 will do, however, without displaying any sort of visual. Special. Many different modules call this group home. 2 modules detect and clean denormal numbers generated by some third-party delays, filters, and other modules' feedback loops, unnecessarily consuming CPU power. The monitor watches over MIDI signals and plugs status changes. The OS command modules carries out system commands. Voice combiner converts polyphonic signals to mono. Random voltage generates, as you guessed, random voltages. SynthEdit does not enable feedback, bar one exception. You can use the special feedback delay module to create feedback loops. Connect the feedback module's output to any module's input and the latter's output to the feedback module's input to configure feedback loops for delays and the like. Note that this feedback is not sample-based. It is latency, and its latency amounts to about 2 milliseconds at 44 kilohertz sample rate, depending on the buffer audio size. So feedback is a bit of a headache, as it's not possible in the audio domain, as far as I know, to do real feedback that a hardware equipment might be able to perform. And in the version 1.4, we have all sorts of feedback modules, not just volts anymore. And it does give you a delay timeout. So just wanted to touch on that right quick. Subcontrols. Use these modules to build controls and GUI features. An entire chapter of this book is devoted to these sophisticated tools. Synths. This container contains 2 drum modules, a subtractive synth, phase distortion synth, and a FM synth example. In 1.4 currently, there's the minimal synth, which is just a very basic synth. We do have the PD303, which is the phase distortion example, and polysynth 2, which is, of course, the multi-oscillator polysynth. And these are available for perusal and investigation for new SynthEdit users. They are quite handy. However, it is nice to follow other guides, as these aren't quite labeled very well. And the drum examples are no longer available in SynthEdit 1.4. VST plugins. SynthEdit lists all VSTi plugins found in the location you specified. Edit preference, file locations, VST plugins. Some folders may be created in that directory when their contents listed as submenus. So we have a figure 1.2 of VST effect, super phaser, it says. And MIDI in, our channel, 2 signals in, 2 signals out. So obviously it's a type of phaser. Though SynthEdit lets you load and embed VSTi plugins in your structure, the GUI does not appear if you embed it in your VST. If you embed VSTi plugins is MIDI enabled, use MIDI controller data to manipulate it. Check the plugins documentation to learn which controllers you may use. Heads up, before releasing a plugin with an embedded VSTi, check if the license permits you to do this or contact the author to get permission. So yeah, this isn't really working because this is a 64-bit environment. It'll only generally load 32-bit plugins. I'm not sure how it bridges. It's just a broken function, as far as I know. Just also for copyright issues. I imagine it was probably abused. So it does work in SynthEdit 1.4, 32-bit. However, in 64-bit, it doesn't seem to be possible to actually load a 64-bit plugin into your workflow, which would be nice as far as being able to use tools like Span. However, that's not the case. It has been deprecated or depreciated, however you want to say it. Waveform. This menu lists sound generating modules. There are 3 types of oscillators. The oscillator module generates band-limited sine, saw, ramp, triangle, and pulse waveforms, offering oodles of modulation options. It also serves as a low-frequency oscillator and generates white and pink noise. White noise frequency spectrum is flat, whereas pink noise frequency spectrum drops by 3 decibel per octave and yields smoother highs. It's funny that it says that, whereas white noise may be flat, but to the human perception, it's not. Because every time I look at white noise in a spectrum, it's not flat. However, that must be the case. It must be like digitally flat. And pink noise is perceptually flat, whereas brown noise is perceptionally flat. Pink noise is, I don't know. Pink noise is equal power, as far as I know. White noise must be equal, I don't know, equal frequency. So we have figure 1.21, sine, triangle, saw, and pulse waves. And we can see there's a picture of them being generated directly out of SynthEdit. Phase distortion oscillator distorts a sine wave's phase to create complex waveforms. Introduced by Casio with the CZ synth line in 1984, phase distortion is much like FM synthesis, or frequency modulation synthesis. The sound font oscillator loads and plays selected sound banks and patches from sound font files, SF2, .sf2 files. It renders sample data only without envelope, filter, and velocity settings. The ADSR module creates amplitude, filter, pitch, and user envelopes. ADSR stand for attack, decay, sustain, and release, respectively, also known as an envelope generator. Attack controls how fast the signal reaches peak level when the player presses a key. Decay controls how fast the signal falls from its peak to the sustain level. Sustain controls the level at which the signal remains until the player releases the key. Release controls how fast the level returns to zero when the player releases the key. Figure 1.122 or figure 1.22 rather, an ADSR envelope. We have the level and time. We have a illustration. It looks sort of triangular and it demonstrates the ADSR flow path. Third-party modules. You can create what is in SynthSpeak called a third-party module using SynthEdit SDK, software development kit, and say a C++ compiler. Whatever your heart desires, oscillators, filters, effects, logic operators, and many more. Someone somewhere offers a third-party module to fit the bill. The occupying data on Wizoo Books SynthEdit third-party modules. You can create what in SynthSpeak is called third-party modules using the SynthEdit SDK, software development kit, and say a C++ compiler. Whatever your heart desires, oscillators, filters, effects, logic operators, and many more. Someone somewhere offers a third-party module to fit the bill. SynthEdit automatically lists all folders and modules found in the modules directory, so you can create more folders and copy third-party modules. So that concludes Check me out on YouTube at JWPTube, Facebook, JWP Meta, Twitch, JWP Stream, Patreon, JWP Patreon, and Discord, link in description. Thanks for watching. Until next time.